Welcome to my channel Chemistry by ANR. We have explored about structure of atom. We have explored about position of elements in the periodic table and the periodic properties. So now it's time for us to explore chemical bonding chapter. So let's plunge into the concept and have some fruitful interactions and discussions. Hello all of you. Today's discussion is about chemical bonding. What is a bonding? Bonding means any type of attractive interaction. So the attractive force which holds various constituents, that is atoms, ions, etc. together in different chemical species are called a chemical bond. This is your NCERT book. So here it is saying that any type of interaction that exists between atoms, between ions, for which that gets held together, that is known as a chemical bond. There are various types of chemical bond that we are going to discuss later on, and now I'll try to get your focus on this part, that is Cauchy-Lewis approach to chemical bonding. According to this Lewis picture of the chemical bonding, what has happened is they have introduced certain terms called kernels. That is, the atoms are positively charged kernels, and these kernels are the nucleus plus the inner electron. Not the valence shell electron, but the inner electron, and the outer shell that can accommodate a maximum of 8 electrons, not more than 8 electrons. As per the octet rule, we know that elements can have a maximum of 8 electron, and every atom wants to achieve that stability, 8 electrons in its outermost shell, and want to get a noble gas-like configuration, barring helium that has a duplet configuration. So here we can see that the Lewis postulate is how to draw. The Lewis symbol says that the stable outer octet of electrons, the one which I just now said, that tendency of the atoms to get a stable configuration, to get a stable octet configuration of electron, 8 electrons in its outermost shell, and maybe if possible a duplet configuration. Now Lewis symbols means we are taking the elements, we are taking the atoms of those elements, and then we are writing how many valence electrons are there in those elements in order to see what is the nature of the chemical combination of those elements. This is an example of the second period elements. In the periodic table we have seen here the principal quantum number is n is equal to 2, second period elements. Lithium is a group 1, beryllium group 2, boron is group 13, carbon 14, nitrogen 15, oxygen 16, fluorine 17, and neon is 18. So they are all the second period elements having group numbers 1, 2 and 13 to 18. What happens in between? In between, that means 3 to 12, they are the D block elements that we have seen in the periodic table chapter. Now, lithium has only one valence electron, so there is only one dot. The number of dot over the elements, over the atoms of the elements, shows how many valence electrons are there. Beryllium has 2 dot, it is group 2. Now boron has a group number 13. Like lithium has group number 1, it is 1 dot. Beryllium has group number 2, there are 2 dots. But boron has a group number of 13 and it is having 3 dot. Why? Because for such cases, what happens? It is 8. What is the valency over here? See, either it is group number 13 means here I will say 13 minus 10. Okay, that's equal to 3 valence electron. Because 10, why? Because D block elements are there. 10 groups are there. So for group number 14 also, number of valence electron will be group number minus 10. So 14 minus 10, 4. So 15, group 15 goes on, same. Okay, now you may say that, okay, group 15 has what? If I say 15 means 15 minus 10, I got a 5 valence electron. So nitrogen family has 5 valence electron. Now when I say nitrogen family, it means nitrogen and all elements belonging to group 15, that is nitrogen family. Oxygen family, 16 minus 10, so 6 valence electron. 17 minus 10, fluorine family, so it is 7 valence electron, and 18 minus 10, 8 valence electron. And the valence shell can accommodate a maximum of 8 electrons, for which this is a noble gas configuration. This is a noble gas configuration, and it has an octet configuration, a stable configuration. Okay, I hope this part is clear. Now, significance of Lewis symbol. Okay, so significance of Lewis symbol, let us see over here. I said that it shows the number of valence electron. Now this number of valence electron helps to calculate the group valence. That is what? That helps to calculate what group it is. Because if I say there are, let's go back to that example. If I say that nitrogen has a 5 valence electron. Now if I say from this, you tell me in which group it is. Of course 5 plus 10, 15. Oxygen has 6 valence electron. I say which group it is. Then you'll say yes ma'am, it is having 6 valence electron. I do a plus 10 and I get 16. So you are correct, it is 16. So like if I know the group number, I can talk about how many valence electron it can have. If I know the valence electron, I can even talk about the group number. So Lewis structure, Lewis symbol, it actually includes the element, the symbol of that element, along with how many valence electron are there. So here, according to Kaushal, in relation to the chemical bonding, let us see that in the periodic table, highly electronegative halogens, that means if I talk about highly electronegative halogens, that means it is group 17 elements, halogens, and highly electropositive alkali metals means group 1 elements. They are separated by the noble gas. That means one period to another period I am talking about. If this is my nth period, if it is my nth period, then this one I am talking about n plus 1 period, that is the next period. They are separated. Or I can talk about n minus 1 also, n minus 1 period. They are separated by noble gases. Okay, the formation of a negative ion from a halogen atom. If I say halogen is X, I get a negative ion. That means it is group 17. When it gets an electron, its configuration is similar to that of noble gases. Because after getting an electron from 7 valence shell electron, it becomes 8 and it gets octet configuration. Now, for positive ion, that means again I will talk about alkali metals. Alkali metals can be sodium, can be lithium, can be potassium. So but when I'm talking about alkali metal, group 1, let me talk about sodium. One example, I'll get Na plus. Okay, so is associated with gain of electron. Why gain of electron? That means here, gain of electron. Now here it's associated with loss of electron. Halogens are associated with gain of electron and getting a negative charge. Okay. Now sodium, if it loses 1 electron, sodium on losing 1 electron, it will get Na plus, means the previous noble gas configuration it is getting. The previous noble gas configuration. Halogen gaining an electron, X gaining an electron, it gets this noble gas configuration corresponding to the same period. Okay, so Na plus gets a noble gas configuration, X minus gets a noble gas configuration. So it always has a tendency, group 17 elements, halogens have a tendency to gain electron in order to get stability. Now group 1 elements, they will have a tendency to lose an electron. Group 2 elements, alkaline earth metals, will have, like calcium, will have a tendency to lose 2 electron and get a Ca2 plus, which is a noble gas configuration. Okay, so noble gas configuration means octet configuration, NH2 NP6 configuration, except helium, which has a duplet configuration I have told. So this type of interaction that exists between the positive and the negative ions are known as electrostatic interaction, and the type of bond is known as electrovalent bond, which we can see in the formation of NaCl. Sodium has neon configuration. Neon has 10 electrons, so neon 10, and sodium has atomic number 11, so neon 10 3s1. After losing an electron, it's I will say it is minus electron. Since here there is plus electron, I am not writing minus electron. So it loses an electron, and that electron goes from 3s and it gets neon configuration, neon 10. That is a noble gas configuration. Cl gains an electron and forms a Cl minus. Cl was what? It is 17 atomic number. So neon 10, then 3s2, 3p5. So here we can see 2 plus 5 in the outermost shell, that is n is equal to 3, for which it has 7 valence electron, right? Now on getting an electron extra, it gets what? P6 configuration and H2 configuration, which is fully filled, and that corresponds to argon 18, the next noble gas configuration. Now you can say that, ma'am, why? It can lose 7 electron and it can get a neon configuration as well, because neon is also a noble gas. Then I will say, no, my dear. To lose 7 electron is not that easy than to gain 1 electron energetically. So if it gains only 1 electron, it will get argon 18 configuration, which is much easier. So let us see the formation of CaF2. Here again, calcium loses 2 electron to form Ca2+. So calcium has 20 atomic number, argon 18 and 4s2. If it loses 2 electron, it gets argon nucleus, argon configuration, I'll say. So argon 18 configuration, for which it gets octet configuration. Fluorine on gaining 1 electron gets F minus configuration. So it has what? Fluorine has how many electron? Fluorine has 9 electrons, atomic number 9. So helium is 2 plus 2, 4 plus 5, 9. So now here again I will say for fluorine, the number of valence shell electron is 7. To lose 7 electron is much difficult than to gain 1 electron and get a fully filled second principal quantum number configuration. That means a neon 10 configuration. So fluorine has a tendency to form F minus, calcium has a tendency to form Ca2+, but this calcium can donate 2 electron to 2 fluorine atoms in order to form what? Twice F minus configuration. So Ca2+ plus twice F minus will form CaF2. That is how CaF2 is formed. And this type of bond, this type of interaction is known as electrostatic interaction, electrostatic attraction between the positive and the negative ions, and the bond is ionic bond, or I will say electrovalent bond. And what is the electrovalence? Number of electrons gained or lost. In case of calcium it is 2, in case of fluorine it is how much? 1. Okay, so but I have 2 fluorines, so how many total gained and lost? Calcium loses 2 electron, fluorine or chlorine gains 1 electron. Okay, so this is what we are seeing over here. Next is the octet rule, which I have already told you that every type of bond will try to actually fix this octet rule. How? By either gaining or losing, or by sharing. So according to this, atoms can combine either by transfer of valence electron from one atom to another, that is the electrovalent bond, or by sharing of valence electrons. Moving on to covalent bond formation. Covalent bond is actually obtained by sharing of electrons. Which electrons? Of course, valence electrons. So Lewis-Langmuir theory, that is, we can obtain by covalent bond, by sharing of electrons, we can obtain homoatomic molecules, or we can obtain heteroatomic molecules as well. Even we can obtain molecules having a multiple bond like O2 or like N2. These are all covalent bond formation. So the first example, which is over here, we can see this is between two chlorine atoms forming a Cl2 molecule. Chlorine is a group 17 element having 7 valence electron. How many? 7 valence electron. So this is your Lewis symbol, 7 valence electron. It needs one more electron. So one chlorine needs one more electron, the other needs one more electron. So no one can actually donate or gain in order to fulfill this requirement. What it can do is they can only share. So when you see this region, here you are seeing 2 electrons. One electron belongs to one Cl, the other electron belongs to another Cl. So for which this chlorine can show that see, I have 7 plus 1, I have 8 electrons. The other chlorine can also show that see, I too have 7 and one more electron that I have shared from the next, my neighbor. Okay, so I can also have octet configuration. So this is the octet configuration, and there is a covalent bond formation between one Cl and the other Cl. So I can say this is the one electron of this Cl, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, 7. So the one which is forming the covalent bond, that is your bonding electrons. These are the bonding electrons. And the electrons which are not involved in the bonding, existing in pairs, they are non-bonding electrons. They are the non-bonding electrons, and they are existing in pairs, and so they are known as lone pairs of electrons. They are known as lone pairs of electrons. Next, this was a homonuclear one, homoatomic one rather, I'll say. So here there are certain things. The dots represents the electrons. Such structures are referred to as Lewis dot structure. So the formation that is shown by the dots, that is the Lewis dot structure in order to show the formation of covalent bond. Lewis dot structure in order to show the formation of the electrovalent bond that we have seen in the previous example. So here each bond is formed by sharing of electron pair between atoms. Now each combining atom contributes at least one electron for sharing. Now the combining atoms attain the noble gas configuration, octet configuration. That is the reason why they are sharing their electrons. Now examples like water, carbon tetrachloride, that is being shown here. This is H2O, 2 hydrogen, 1 oxygen. This is CCl4, 1 carbon and 4 chlorine. Let us see. Now hydrogen has only 1 valence electron. Oxygen has how many? 6. I am drawing another hydrogen with 1 valence electron. Now if hydrogen gets another electron, it will get a duplet configuration, helium-like configuration. And oxygen, it has 6 valence electron. So 1, 2, 3, 4, and I am drawing this 5th here and the 6th here. Why? Because this is shared. This is shared. Now you notice oxygen has its own 6 and 2 from the 2 hydrogen, and telling I have 8 now. So I have octet configuration. Now hydrogen is telling I have 1. I have borrowed and shared, rather I'll say shared 1 from oxygen, and now I can show my duplet. So is this hydrogen telling I can show my duplet? So you have a duplet configuration for both the hydrogen and octet configuration for the oxygen. Next, going on to CCl4. Carbon. Carbon has 4 valence electrons. So this is 1, 2, 3 and 4. Chlorine belongs to group 17 having 7. So 1, 2, 3, 4, 5, 6. Always draw the electrons in pairs. And when you are drawing, be confident about the dots. Don't just scribble something somewhere, then the teacher will think you are not clear with the concept. So the next Cl again here can have 1, 2, 3, 4, 5, 6 and 7. So like this, I have to make 4 Cl. So I'll tell now, refer to the diagram. Here see the bonds, it is like this. So they have shown it sidewise. So this is one bond, another bond, another bond and another bond. I will insist you to make the electrons like this only so that you can make the bonds easily. So now chlorine is telling I have 7 and I have shared 1 from carbon and I have octet. Each chlorine thus gets octet. And carbon says I have 4 and I have 4 partners, Cl, those who have shared 4 electrons, and so I too have octet, 4 plus 4. So each element over here is having octet configuration. Next, seeing the case of multiple bond. I said O2 formation, I said N2 formation. Here we can see CO2 molecule. What is happening? Carbon has 4 electrons. So this is the 4 valence electron carbon is having. Oxygen group 16, 6 valence electron. This is 1 lone pair, second lone pair, 4 electron. This is 5, this is 6. So 1 lone pair, second lone pair, 4 electron, 5, 6. So now oxygen is telling I have 6, I want 2. So carbon shares its 2 and so this is the octet of oxygen. This is the octet of another oxygen and now this is the octet of carbon. Thus, this is how CO2 molecule is getting formed. See here what is being shown, C2H4. C2H4. So what is the name? It is ethene. The name is ethene. So carbon has 1, 2, 3, 4. And this carbon 1, 2, 3, 4. Okay. So now this carbon is telling I have 4. Now I need 4 more. So 1 from hydrogen, second from hydrogen, third from carbon and fourth from carbon. So this carbon actually gets octet like this. Okay, 8 electron count and see, it is 8. And this carbon gets 8 electrons like this. This is the octet. And hydrogen gets a duplet like this. This hydrogen also gets a duplet like this. This is also a duplet and this is also a duplet. Always remember one thing, for a multiple bond formation, though I can say it later on, yet I will tell to focus on the point that when I am writing C double bonded C and I am writing H and H, here again a H and H, then focus on this factor that this is a sigma bond. What it is, I'll tell you. This is a sigma bond. This is also a sigma bond. For a multiple bond, there is 1 sigma, rest pi. So there are 2. So that's why one is sigma, the other is pi. Okay. So what is sigma? What is pi? We are coming to it just few minutes later maybe. Okay. So when combining atoms share 3 electron pairs, that is we are seeing in nitrogen. This is 1, 2, 3, 4 and 5. 1 lone pair of 1 nitrogen, another lone pair of another nitrogen. This nitrogen attains, it has 5 plus 3. that is the octet. And for this nitrogen, this is the octet configuration. So this is the formation of N2 molecule. Next, C2H2. C2H2, it is ethine. This is an alkyne system. Ethine, common name is acetylene. Okay, common name is acetylene. So now this again, the carbon has 1, 2, 3, 4 of its own. This is 5th, 6th, 7th, 8th. So this is the octet of one carbon, and this is the octet of another carbon. This is the duplet of hydrogen, and this is the duplet of hydrogen. Okay, so this is how you are getting the Lewis structures for the formation of the covalent bonds. Now we have to discuss about Lewis representation of simple molecules that can be ions also or neutral molecules as well. If it is a neutral molecule, we have seen such discussions. Okay, now for anions and cations, what happens? Anions means it has an electron extra. So each negative charge would mean addition of one electron. Anion means if I say X minus, that means one electron is added to it. If I say 2 minus, that means 2 electron is added. For cation, if I say a positive charge, for each positive charge, it actually means subtraction, loss of an electron from the total valence electron. Okay, so that is what we have seen. Suppose CO3 2 minus ion. What is the name of this ion? The name of this ion is carbonate ion. It is carbonate ion. So the two negative charges will be over the 2 oxygen. Okay, so there are 2 additional electrons. So I'll say oxygen is more electronegative, so it will be over 2 oxygen. For NH4 plus, there is a 1 positive charge by the loss of 1 electron from the group of neutral atoms. Okay, now you may say how to draw the Lewis structures. For this, some hit and trial methods you have to follow after drawing the skeletal structure of the compound. Align the atoms, and then you have to see to it how octet configuration can be attained by bonding or by the sharing of electrons. Now, some knowledge, prior knowledge you should have regarding the basic structure. Then you will see that what happens is how to draw. If you use the concept of bonding, if you use the concept of octet rule, you can get the final structure. Some examples, let us see. H2. H2 is what? Homoatomic molecule, same type. All hydrogen and hydrogen. So here it's a simple one. We have seen O2 is a simple one. O3, ozone, is actually not a simple one. We can see different types of bonding here. So what are the types of bonding we can see? See here, it is a covalent bond. Okay, a multiple bond. 1, 2, 3, 4, 5, 6 and 7, 8. This is how octet configuration is attained. What about this oxygen? It has a positive charge and here it has a negative charge. Why? Because O3 again is neutral. Then why this positive charge and negative charge? The reason is this oxygen had to donate its electron pair and form a coordinate bond. Then it actually looks like oxygen, this is donating an electron to this, because this oxygen which is having a negative charge is having 6 electrons valence shell and getting 2 more from the oxygen that is donating. But after donation, every coordinate bond is also known as dative bond, but after formation of the dative bond or formation of the coordinate bond, it actually behaves like a covalent bond. It actually behaves like a covalent bond because after donation, those two are shared. Okay, suppose if I give an example, say two children are telling that, okay, I have 3 chocolates, you have 2 chocolates, I am giving you one. So the one which is giving becomes one less and the one which is gaining becomes one more. Okay, this can be a case of an electrovalent bond formation. Or maybe one is having 1 chocolate, the other is having 1 chocolate, and they can say, we both are having 2 chocolates, we'll share and have it. Okay, so now here what happens when the concept of sharing comes, that is a covalent bond formation. Now what happens, maybe that one is having 4 chocolate and the other is having say 6 chocolate, and now they are telling that, okay, the one which is having 6 chocolate, I want to give you the 2 chocolates, but again after giving it will be shared between us. Understood? So the one which is giving becomes the donor because the person is giving. So the atom which is donating, that gets a positive charge. It's a donor atom. The other atom that is accepting becomes the acceptor atom and gets a negative charge because it's not chocolate, it's electron. Okay, so now the one which donates the electron is a positive charge, which gains the electron is a negative charge. After the formation, it is shared, and so if I actually make a dative bond, I will not give the positive and negative. Understand? So this is 1, 2, I'll say 3, 4, 5, 6. And here again, this will be 1, 2, 3, 4 donated now. So here again, this is 5, 6, which is donated. Now this is having 1, 2, 3, 4, 5, 6, accepted 2 and showing octet. This is it. But if I don't give the positive charge, don't give the dative bond, then I have to show a positive and negative in order to tell, okay, this is a donor and so it gets a positive charge. The other one is an acceptor and so it gets a negative charge. Now, talk about NF3. NF3 is a trifluoride, no? So here what is happening, fluorine is what? It needs only 1 electron for octet, and nitrogen has 5 valence electrons. So what it happens, it gives 3 for the bonding and 1 remains as lone pair. So that is the lone pair. See here, whichever is non-bonding is the lone pair. Okay, so these are the lone pairs. You have to show them in pairs. These are the lone pairs for fluorine. Okay, so CO3 2 minus, important for all exam. O3 important for all exam, HNO3 important for all exam. CO3 2 minus में क्या होता है? There are 2 minus means 2 electrons. 2 electrons can be given to oxygen like this. So there is a double bond between carbon oxygen and the single bond over here. Actually see this oxygen, 1, 2, 3, 4, 5, 6. It gets 2 from carbon for showing or getting octet. Carbon gets 1, 2, 3, 4. This is 5, 6, 7 and 8. Okay, so this is the octet for carbon and this is the octet for this oxygen. Likewise, I'll say this oxygen again 6, 7, 8, like this it is getting octet. Now this 8, this electron, oxygen gets this electron because of the negative charge and this electron also because of the negative charge. 2 negative means 2 electron extra. HNO3 also same thing. Here you are seeing it is a neutral molecule. So if you have to show the dative bond, show it in this manner. This is double bonded O, this is a dative bond and this is OH. Okay, so oxygen over here is having 1, 2, 3, 4, 5 and 6. Hydrogen 1 electron. Nitrogen 1, 2, 3 and here 4, 5 being donated to the oxygen, and this oxygen has 1, 2, 3, 4, 5 and 6, and it gets 2 more by donation from nitrogen and gets octet. See this oxygen, 1, 2, 3, 4, 5 6 and gets 2 more from nitrogen for octet. So here nitrogen acts as donor atom and so it gets a positive charge. Oxygen acts as acceptor atom and so it gets a negative charge in the dative bond formation. Next, moving on to the example problem, you have to draw the Lewis dot structure of CO. So these are certain hit and trial methods in order to say whether there is octet configuration achieved or not. Finally, you land up to this. See carbon 1, 2, 3. You are getting here. It's a triple bond and you say that carbon over here has 4 electrons. Okay, it has 4 electrons. So here again 1, 2, 3, 4, 5. How you are getting this carbon monoxide again? So how you are getting the octet configuration? So how can you say Lewis dot structure is this? So this does not complete the octet. So what will you do? That we have to resolve the issue by multiple bond formation, and then can I say that I can write it in this manner, that this is 1, 2, 3 and 4. So 1, 2, 3, 4 and see here 1, 2, 3, 4, 5, 6. Oxygen is getting octet 6 electron and 2 electron from here. And carbon has how many electron? 4 valence electron, right? So 4 plus 2, 6. So it is actually not getting octet here. So you don't have any other way rather than forming a triple bond. So when we see the structure of CO, then we wonder, how is it possible that carbon is having here 5 electron? Carbon is not having the 5 electron. Let us see what is happening here actually. Carbon was having this only 1, 2, 3, 4. अपना तो 4 कॉइन है, उससे ज्यादा कॉइन्स तो है नहीं. ऑक्सीजन का क्या था? ऑक्सीजन का 6 कॉइन था. 1, 2, 3, 4 and 5, 6. So it was possible how when this lone pair was shared between carbon and oxygen and this lone pair was shared between carbon and oxygen. Then what we get is carbon. Here there is one single bond, so I write it in this manner. Lone pair getting shared one bond, lone pair getting shared another bond. Oxygen here, so it gives 2 lone pair, remaining is 1 lone pair. And carbon का तो अपना यहाँ पे क्या था? 2 electron, so वो तो है ही. And here carbon is having 1 lone pair like this. Now here you can assume these 2 electrons are from oxygen, these 2 electrons are from oxygen. Carbon का एक यहाँ, okay, एक यहाँ और एक यहाँ, एक यहाँ, 4. Okay, so now after the sharing, it is no more belonging to only carbon and belonging to only oxygen because it has been shared. So after sharing, you get a triple bond like this, और कार्बन का लोन पेयर रह गया एक यहाँ पे और ऑक्सीजन का लोन पेयर रह गया एक यहाँ पे. This is how CO is getting formed. Okay, so you may have doubt over here how it is getting formed. It is formed in this manner. Okay, Lewis structure of nitrite. See, you should know the difference between nitrite, nitrate, all these things. NO2 minus is nitrite, NO3 minus is a nitrate. Likewise, sulfate, sulfite, sulfide, all these things you should know. Okay, so this is again the same thing, hit and trial method. NO2 minus nitrite, what you are seeing. So 2 minus means 2 electrons to be added. 2 electrons to be added to each oxygen, which is more electronegative. Have you noticed in each of the structures, the less electronegative one is kept as the central atom. Okay, so now here let us see what is happening. 2 oxygen is getting a negative charge. Nitrogen ka 1, 2, 3, 4 and 5. Oxygen 1, 2, 3, 4, 5, 6. And here this oxygen 1, 2, 3, 4, 5, 6, 1 electron extra. Why this is NO2 minus? So it will be not 2 electron, it will be 1 electron extra. So either you add to this oxygen or you add to this oxygen. These two structures are equivalent structures. They are similar structures. Okay. Next, moving on to formal charge. Formal charge means what? It is how much charge we are going to assign hypothetically over each atoms, okay, in the molecule. Now, Lewis dot structure, they do not actually represent the actual shapes of the molecules. You are predicting. Okay, it's prediction. For polyatomic ions, the net charge is possessed by the ion as a whole and not by the particular atom. So, how much is the charge over the particular atom? So the formal charge of an atom in a polyatomic molecule or ion may be defined as difference between the number of valence electron of that atom, valence electron of that atom in an isolated or free state, and number of electrons assigned to that atom in the Lewis structure. So Lewis electron or Lewis structure electrons, but we have a particular formula for it, and this is the formula. That is, formal charge of an atom in a Lewis structure is equal to total number of valence electrons in the free atom minus total number of non-bonding electrons. That means how many lone pairs are there. Non-bonding are the lone pairs. Minus half of total number of shared pair of electrons. So I will say the bonding electrons. Okay, half of the bonding electrons. That is the formal charge. Now we are going to apply it over here, and so we will get the formal charge. See, let us consider ozone molecule. Ozone molecule is O3. Now this was the type of the bonding. If I say the dative bond has been shown by a covalent bond. Now here O3, the carbons are tagged as 1, 2 and 3. When you tag them, let us see the central atom, which is marked as 1, how much charge it can contain. What was the formula? Formula was formal charge is equal to number of valence electron minus the lone pairs of electron minus half the shared pair of electron or bonding electron. So this oxygen 1, it has, each oxygen will have 6 valence electrons, so 6 minus lone pair. It has, how many electrons are there in the lone pair? So there are 2 electrons in the lone pair. Okay, so here it is written minus 2 and minus half, how many electrons are shared? So how many electrons are shared over here? This is bonding. See, one bonding and second bonding. So it actually means each bond has 2 electrons shared. So 4, and this is 1. So that is again a double electron. So 3 bonds we can see, and 3 into 2, there are 6 electrons associated with the shared pair of bonds. So this is half into 6, which comes out to be plus 1. So we can write plus 1 charge over this oxygen. We are writing plus 1. You go to oxygen number 2. Oxygen number 2 has how many valence electron will be 6. Lone pairs, see there are 2 lone pairs. So each lone pair contains 2 electrons, total 4 electrons minus half the shared pair. So this oxygen is having only 2 bonds. So 2 bonds means 2 into 2, 4 electron. So the formal charge over here is 0. So that's why we are having no charge here. Next, we are going to oxygen number 3. So valence electron remains the same. Minus lone pair. Let us see. This is 1. This is 2. And this is 3. Now, please remember how I have told you. I have told you that Oxygen 1 is the donor, oxygen 3 is the acceptor. That gives the dative bond. After the formation of the dative bond, it behaves like a covalent bond. But oxygen 3 had 6 electrons as non-bonding. So that means what? These 6 electrons were actually oriented as 3 lone pair. So here there are 6 non-bonding electrons, or 6, I'll say 3 lone pair. Now half of the shared pair. Shared pair is this bond only. So that is one bond corresponding to 2 electron. So the charge is -1. So what you can see over here is 1 negative. This is how formal charge is calculated. Okay. So, formal charge actually help in the selection of the lowest energy structure from a number of possible Lewis structures. So, if I have more than one possible Lewis structures, which is the lowest energy structure that we will get. How? Generally, the lowest energy structure is the one with the smallest formal charge on the atoms. The formal charge is a factor based on a pure covalent view of bonding, in which electron pairs are shared equally by neighboring atoms. So minimum formal charge, here it is +1 -1 gives 0. So there is no charge over the molecule. So O3 doesn't have any charge over the molecule. Here we can see limitations of octet rule. Octet rule is not always valid. If we see incomplete octet, where we can see it? The central atom LiCl having only one covalent bond between Li and Cl. So here it has, actually it has what? Less than octet configuration. Okay, so BCl3, BeH2, AlCl3, okay, having less than octet configuration. Why? See, AlCl bonds, there are 3 such AlCl bonds. So total number of electrons is 6 electrons around aluminium, which is less than 8 electrons. Okay, so these types of molecules like AlCl3, which has less than octet configuration, you know, later on we will see these are known as Lewis acids. Lewis acids means they have less than 8 electrons in their central atom, in the valence shell of the central atom, and for which they are capable, they have the tendency of accepting electron in order to attain an octet configuration. So odd electron molecules like NO, you know, here in molecules with an odd number of electron means single electron, nitric oxide NO, nitrogen dioxide NO2. Octet rule is not satisfied. NO2 always have a tendency to dimerize and form N2O4. It is a dimer of NO2. Okay, why? Because NO2 is something like this. This is one electron, it forms a double bond and it forms a coordinate bond with O. So it is what? 1, 2, here it is 3, 4, and this is the 5th. So another nitrogen will have this type of structure, NO2 molecule, and so it has a capability of forming a bond between 2 NO2 units and forming N2O4, which is a dimer. Okay, so the expanded octet also, the central atom having more than 8 electron, that is known as expanded octet. The central atom having more than 8 valence electron. Okay, so here we can see PF3. PF3 has single bonds here, covalent bonds, there are 5. So 5 2s are 10 electron. SF6, 12 electrons. Why? 6 covalent bonds are there. H2SO4 has 12 covalent bonds. Okay, I mean it has 12 electrons around sulfur, so which is greater than 8. So that is what? That is a violation of the octet rule, limitation of the octet rule. That's all for today's session. See you in the next session. Till then, bye all of you.